Hey, what's going on? It's Justin Dickmeyer from engineeringtrainingexam.com. And in this video, we will discuss annual cost. In this video, we will define the topic of annual cost, walk through the general workflow of solving such problems, and jump into working an example of something we may see on the exam. The topic of annual cost falls under the main category of engineering economics. Equations, symbols, tables, and information on the various topics covered in engineering economics can be referenced on pages 114 through 120 of the NCEES Applied Reference Handbook, 8th edition, 2nd revision. It has been established in previous videos that money does not have the same value at different points in time. For this reason, we need tools, tables, formulas, and various economic factors to reference when it is necessary to compare two complex alternatives. Sometimes when we are analyzing alternatives, it is more convenient to evaluate them in terms of their annual value or cost. As an example, it may be that we know the potential annual benefits of a particular investment, but need to determine the overall cost of the alternative to see how it compares to others. Through this analysis, we can determine if there will be a positive cash flow coming in, or in other words, if our benefits will cover our costs. When analyzing two alternatives, it is desirable first that the cash flow is positive, and second, which alternative will benefit us the most over the period of the analysis. So let's go over the general workflow. The goal of an annual cost problem is to convert various costs into annual equivalent costs that we can then compare to defined benefits. We may be given a problem that requests that we convert just one series of transactions, or we may be given a problem that we're asked to compare two unique investment or projects, each with individual periods, interest rates, and transactions. The general workflow is the same regardless of whether it is a single or a multiple alternative problem. The steps are as follows. Number 1, define the various benefits and costs identified for the alternative and the period of the entire investment. Number 2, determine the desired rate of return or interest rate. Number 3, using the uniform series formulas in the table on page 114, as well as the compound interest table starting on page 116 of the NCEES Applied Reference Handbook, convert the costs into a uniform series of annual costs. And number 4, regardless of what we are analyzing, we are typically looking for our benefits to be maximized over the period of the investment. So let's go through an example. An engineering firm has a desire to purchase a $55,000 machine. The machine would require $3,500 in maintenance costs starting at year 1, maintaining constant yearly throughout the life of the machine, which is 8 years. If the estimated salvage value of the machine is $4,000 and it is expected to generate $15,000 annually in returns, is this an acceptable investment for the firm? Let's assume a minimal attractive rate of return, or MARR or MAR, of 12%. So here's the solution. The goal is to determine if the $55,000 investment in a new machine would benefit the firm. When we evaluate a single investment using an annual cash flow analysis, the investment is considered acceptable when the equivalent uniform annual benefit, or EUAB, is greater than the equivalent uniform annual cost, or EUAC. Or in other terms, EUAB minus EUAC is positive at the desired MAR. The MAR for this particular investment is 12%. This is a three-part problem. First, we need to convert all the disbursements into a present value and then spread them out as a EUAC, or equivalent uniform annual cost. The second part requires us to convert all the receipts into an equivalent uniform annual benefit. Lastly, we want to compare those two values to determine whether or not it is an acceptable investment. We can use the formulas found in the table on page 114 and reference the compound interest table starting on page 116 of the NCEES Supplied Reference Handbook. As stated in previous videos, as engineering economic problems get more complicated, it is best to get comfortable using the functional notation version of these equations and referencing the compound interest tables, as it will lead to a much more efficient use of your time. The information that we have been given by the firm is as follows. An analysis period of 8 years, a MAR or minimum attractive rate of return of 12%. The cost of the machine is $55,000. The salvage value is $4,000. The annual maintenance costs are $3,500. And the annual returns generated is $15,000. The goal initially is to determine what the equivalent uniform annual cost will be. Therefore, we need to use the functional notation version of the equations and reference the compound interest tables to determine what the uniform annual cost per interest period will be of all future disbursements. We will use the capital recovery and the uniform series sinking fund written in functional notation, which are A is equal to P times A over P IN, and A is equal to F times A over F IN to determine the equivalent uniform annual cost over the 8-year period. The terms A over P IN and A over F IN can be defined using the given values for interest and period and the compound interest table starting on page 116 of the NCEES Supplied Reference Handbook. So the total equivalent uniform annual cost over 8 years, accounting for all the projected costs, is P times A over P IN plus A minus F times A over F IN. Referencing the compound interest tables for 12% on page 120 of the NCEES Supplied Reference Handbook, we reference the appropriate values for the period, our far left column, and work our way horizontally and find that A over P, 12% with a period of 8 is equal to 0.2013, and A over F, 12% with a period of 8 is 0.0813. Plugging these values into the equations, we get an equivalent uniform annual cost of $55,000 times 0.2013 plus $3,500 minus $4,000 times 0.0813, which gives us our equivalent uniform annual cost of $14,246. Now for the second part, we need to determine the equivalent uniform annual benefit of the estimate. This is easy enough since the problem states that the firm would generate $15,000 annually in returns. Therefore, our equivalent uniform annual benefit is $15,000. The investment is considered acceptable when the EUAB is greater than the EUAC at the desired MARR. So that gives us $15,000 minus $14,246, which is our costs, which is equal to $754. So the firm will realize a net equivalent uniform annual benefit of $754. Therefore, the investment is acceptable since it is bringing money in annually. Now, there are a few common mistakes that may occur in these problems. First, it is important to note that the feasibility of an investment is always compared by its benefits minus its net costs. It is easy enough to flip this, subtracting the benefits from the costs, which in this case would give you a negative value and would lead you to concluding that the investment is not acceptable. As with any other problem, it is easy to overlook the various costs or benefits. When comparing alternatives, all costs and benefits must be accounted for to ensure you are properly analyzing the true cost of the investments. Otherwise, you will be putting the financials of the firm in jeopardy when they don't play out as expected. Well, that's it for this video. Do you know anybody that would benefit from this lesson? If so, let's try to reach out and help others by sharing this video with them. Also, take a second to like this video and leave a comment and tell me how it will help you move forward in your goal of becoming a professional engineer. And finally, type in engineerintrainingexam.com into your URL bar and visit the site to download for free the transcript to this video along with the example problem and solution we worked. While you are there, you can also sign up for the free EIT Academy Bootcamp, 137 pages and over 50 practice problems and solutions to get you on track to passing this exam.